The main causes of the worldwide diabetes epidemic are chronological age, society, and familial susceptibility. It appears that a number of factors are compounding with the marked increase in type 2 diabetes worldwide. One factor contributing to this increase is an ageing population. With ageing, diabetes becomes much more common. In Australia, 1 in 4 people in their mid-70s has diabetes. The world's population is increasing, but even so, its percentage in terms of people affected by diabetes is predicted to increase over the next 20 years from 8% to 10% of adults around the world. A second factor contributing to the increase in type 2 diabetes is lifestyle, particularly linked in with being overweight or obese. What then is driving this obesity? The simplistic answer is energy imbalance. That is, excessive energy going in and not enough being expended. But it's much more complex than this. It's well recognised there are gene-environment interactions, and it's believed genes contribute from 1/3 to 2/3 of this interaction. But what is it about society and the individual which predisposes them to an increase in body weight? Thirdly, there are familial susceptibilities. For example, people of Caucasian background can cope with much more body weight increase before they would develop diabetes than can, say, people of Southeast Asian or Hispanic background. Over thousands of years, certain ethnic groups have come to cope much better in a famine situation than others in a feast situation. So all data available shows us that some people can cope with higher increases in body weight before the pancreas will ultimately fail.
Familial susceptibilities are nowhere more marked than in a society that has the gene and where the environment is more or less favorable to the development of diabetes. The story of Nauru illustrates the point most vividly. Nauru, a tiny island in Polynesia, was extremely poor in the early 1900s, and the people were hunter-gatherers. They were very fit and healthy. During World War II, Japan invaded Nauru, then moved the Nauruans to another island, Truk, about 1,500 kilometers away, where they lived for the last couple of years of the war. The Japanese worked them hard, didn't feed them, and at the end of the war, Nauruans were in a bad state and a lot of them had died. So they were already poor people who were already selected for people who could survive famine situations. But on top of that, now we've had this additional instantaneous selection for people who had to survive the harshest of harsh treatment inflicted on them. At the end of the war, they went back to Nauru, and then a miracle happened. Arguably, one of the greatest discoveries of modern time is fertilizer, and the major ingredients in fertilizer is phosphate. So multinational corporations scoured the world looking for phosphate. It turned out Nauru was a major stopping point for migrating birds who defecated all over the island, making it a huge phosphate reservoir. These multinational corporations came in, they paid the Nauruan a fortune, and overnight they become extremely wealthy. So now we have this fascinating juxtaposition which happens literally within a few years, where we had selection for people who could survive starvation, suddenly becoming wealthy and starting to eat excessively. They become the most obese and most type 2 diabetic ethnic group on the planet. Their genes had adapted for something completely different to the affluent world the Nauruans now live in. Now, zoom into the story of what happens in the Western world. Imagine what we've got as Nauruans, if you will, scattered throughout our population. So we have got people among us who have got the same sort of genes as the Nauruans and others who do not. We are all exposed to the same environment, but we're not all obese and we're not all diabetic. What should we do in the future?
We have no cure for diabetes, so our focus is on prevention and delay of onset of diabetes and its complications. Large clinical trials have shown that intensive exercise and a diet targeting body weight can prevent or at the very least delay the majority of type 2 diabetes in people at high risk. In fact, we need a whole of population risk strategy because everyone is at increased risk of diabetes as the decades progress. And there are people at particular risk, and they're the ones who might have pre-diabetes conditions recognised on a blood test, or those people with multiple risk factors such as ageing, with an increase in body weight and family history of diabetes. The marked increase in diabetes in certain Asian countries appears to be due to a change in lifestyle in people who are probably genetically susceptible to developing diabetes, and then as they're ageing, their diabetes is showing up. We won't be able to get rid of all diabetes even if we have a panacea because of an ageing population, so the focus needs to be on prevention and delay of the majority of diabetes. Then we need to prevent diabetes complications. They are the traditional ones of eye, kidney and nerve disease, foot ulceration and amputation, vision loss, kidney failure, heart disease, stroke and so on. Screening for a lot of these complications can help prevent them occurring and detect them early. Fortunately, these complications are reducing in a number of countries around the world. This is particularly the case in type 2 diabetes. In Australia, the mortality rate for people with diabetes used to be 50% higher in the general population for people with type 2 diabetes. But over the last 2 decades, it's now down to about 20% increased over the general population in both adult men and women. We have to do more than just targeting overweight and obesity. We need to target in the package those components that markedly increase the risk of diabetes complications: blood pressure, blood glucose, cholesterol, and smoking. There are some exciting developments occurring in technology and medicine as well. One of these will likely be cell transplants, replacing those non-functioning pancreatic beta cells. In the medium term, the artificial pancreas is going ahead. This is able to sense glucose in the body, administer insulin, and to connect the two. Although people with diabetes are living longer and overall having fewer complications, the tsunami of diabetes in the world, particularly in the developing world, means that scientists, clinicians, epidemiologists and public health physicians, among others, need to work better together. Indeed, this is what we are trying to realise at the Charles Perkins Centre.